Hello everyone, this is Bradley. Today this is another knitting tutorial talking about this waving cloth animation. This is again inspired by a Cinema 4D animation recently, but the principle has been discussed in Cinema 4D 9 years ago using X particles. I've recently just uploaded a tutorial talking about knitting on show, which is using the same technique. So today we're just repeating this technique and add some additional information about it. So let's start. So here we're in Blender. As always, we're going to use the presets which you can download for free from the link in the description. Let's add a plane, but I'm not going to add a geometry node on this plane. I need this plane only because I need to add this empty here, which is new curve object for performance. Without a mesh, you cannot really add that. So that's the reason. So I'm going to select and clear the parent because I no longer need this plane. Automatically, it will add a node tree called surface deform. It's essentially used for sculpting, but we're essentially just constructing curves inside. I've already made a knitting unit curve. I've discussed how to model that last time. Essentially, it's just a kind of nervous curve, as you can see. And you just model this kind of shape, and you can modify that later. The most important thing to do this is that I want to use the minimal amount of vertices to construct a smooth curve for instancing. So now within this curve node tree, I have this curve, and it looks kind of very ugly. There are several reasons to that. One is that the curve does not have additional subdivision, so you need to turn that up as high as possible. In fact, the maximum amount is 3. I don't know why. And then we resample curve to have 15 vertices. I think this is already good enough. You can definitely turn that higher, but it's a little bit meaningless in my opinion, and it will hurt the performance since we're going to instance a lot of that. And then we start with a grid. Okay, you can customize the size, maybe 5.5, and you can go to wireframe to look at how it's subdivided. Okay, so maybe this amount. Now we just need to instance onto these polygons. So we take a face point preset. I've discussed that last time. And we take a point instance or instancing on point to instance or resample the curve into the instance socket. Okay, so now actually you probably already realized the relationship between a knitted pattern and the unit we made earlier. That's actually the reason. Okay, we didn't see this beautiful pattern last time due to many different reasons, but now you see that. Now if we go to the material preview node, preview mode, and you disable overlay, you can see there's nothing because you have to realize instance in order to make it shown in render. Okay, actually this looks nice. And in order to add the thickness, you just use the curve, set the curve radius, and take the strip so that you can increase the thickness. So this is kind of idea. Okay, you can tweak all these kind of settings when you are rendering it, but now I'm just going to use the strand. Next thing is to actually displace this plane, because we're not going to do the actual physics. You can definitely do the actual physics within this grid. The process will be the same, but I want to make it as procedural as possible, so we're just going to displace it. And to displace it, there are many different ways. You can use the set position, and then you add a noise 3D. This noise 3D essentially is just a noise texture, but the only difference is its color is going the negative range and the positive range, so that you do not only displace into one direction. So you plug this color into place so you can see the displacement and you can increase the scale. But sometimes you will have intersection because this is not a simulation. So another way that you can potentially do is just to use a normal displacement, which is displacing that's everything on normal, and you use this factor so that it only goes up and down without intersecting each other. Both ways are applicable. It really depends on what you really try to do. Okay, And now if we look at our instance, it may not show to be too much of a problem. It actually does, because it's not orienting itself. Everything is just lying flat, so you lose all these kind of patterns. So what you can do here is you put the rotation into the rotation. But you can also see the rotation becomes very chaotic because we're using the -1 mode. You're just going to align that with the x, putting that to 0. The 1 and 2 is also okay. It really depends on what you try to do. But I think this is good enough. Okay. And to provide accuracy, we are just going to weigh in the edges. So this gives you a nice result because you can see they are sometimes rotating up and rotating down with this displacement. So they're trying to make themselves interlacing each other as possible. Okay, so this is kind of idea. Next, what we do essentially is just animating it. So as last time, we're going to use the proximity 4, but there's one kind of issue. If you plug this proximity 4, so again, we are using this remap 0 to 1. I'm also going to plug this scale into scale so that if we subdivide more, it will change its scale accordingly. So maybe we keep the scale like this. And then now if we try to add more subdivision, so subdivide mesh, you can see it becomes smaller because the face area node inside this scale becomes smaller as well. So everything becomes more procedural as you change the parameter, so that you do not need to keep changing parameters when you're changing the settings. And it actually becomes very beautiful when you subdivide more because it becomes smaller and the details is fantastic. Okay. And this is also why we have to use this new curve, because it will create a lot of problem if you have more sampled curve and other things. Okay. So now if we plug this fourth into the value and we plug this result into the multiply factor, we know that the multiply factor is 4, and we can use an empty. Instead of using empty in this case, I'm just going to use this scale offset so it goes from middle. Okay. So we know our plane, our grid is 5, 5. So just take this scale offset, maybe 5 or 6, 7, something like that. And then you animate this fourth animation. You can see this animation already. If you want to add a noise, you can just use vector noise. And then we try to see it. So we can increase the frequency. If you want to get a sharper result, what you can do is just to color ramp it. It can be as sharp as a constant. So you suddenly have this appearing animation. Da 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 da. Da 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 da. Something like that. So this is kind of idea, and I can kill these ECs. Okay. So we have this result. Of course, there are many other ways to manipulate that, but I'm not going to discuss that for now. Another thing is that you can flip that, as I've discussed last time. So we take a rotate ruler, and we rotate at local axis. So now everything is looking flat, but by rotating x-axis 90 degrees, you can see they flip it up. So now we combine ruler rotation, and we need another 0 to 1 remap, and not this time we're rotating 90 degree to 0, and we reverse the relationship. Okay, so now if I make this animation, so you can see, I hope you can see that clearly in this tutorial. It might be a little bit difficult to visualize sometimes, but this is it. Okay, so this is just an example. You can tweak all these kind of settings about how everything looks like. Okay, There's no right or wrong answer to it. Right now there is a kind of problem. As we are using the displacement to fake this waving animation, we need to obviously move the displacement, and here is where we need to manipulate this custom vector. This custom vector essentially is just the vector socket of this noise texture, and by default it contains a position attribute added to it, and by manipulating this position attribute, for example use a vector mask, we can moving up and down to change the mapping of this noise texture. And this is the same principle as in this noise 3D. So we just use a translated position which contains a vector mask inside, and by manipulating this Z up and down, we are animating it. To make everything automatic, I'm just going to add a time info node and plug that into Z. So that by playing this animation, it will wave itself automatically without any other things. And you can change all these kind of factors. Because we're running the division, so higher the number, slower the animation will be. So it depends on how you want to manipulate that. Again, time info node is also just the same time node with a controllable division math inside. Okay, so there's one additional problem that it may not be very noticeable when you actually do the animation, because this is a fast animation. You just run this for from 0 to 1. But there will be a kind of problem. We are changing the geometry data at this step using displacement, which means the face point position will also be changed. This also means this position attribute inside all this kind of fold will be changed. It will change the evaluation of fold. It will not be very obvious, but it will cause some problem. So ideally speaking, you always want to capture an attribute when you're using fold like this. And since we're instancing our face, then this capture should be working in the face domain. And the position value is a vector, so we take the vector and plug this attribute into the custom vector. You will not notice any major difference, I guess, but it's really the correct way of doing many times when you're using both. Okay. So you're making sure the result of this fold is very consistent as expected. Now I want to talk about some additional displacement that we can do with this pattern. So for the moment, I'm going to disable this normal displacement, and I'm going to take a set position after this realized instance, and we need a noise 3D to displace it. So we plug the color into the offset. So now you can see that we have another displacement. But different from last time we were essentially displacing the original plane, but all these kind of knitted units are keeping their shapes because there's nothing being done during the instancing process and after the instancing process. Right now we're displacing after the instancing process. So now you can see all this kind of spline is being distorted, but the noise is the same as previous, because we're using the same seed. Okay. So there are several problems I want to deal with. One is now you can actually see this kind of continuous flow because we're using a noise of the same seed. If you want to make that really chaotic, you turn up the frequency, then all splines goes to be very crazy. Okay. You can see the start and the end is going off. They don't not look like connecting to each other because they were never connected to each other. But we want to give a kind of illusion that they are connecting to each other. So how do we do that? Here, I'm going to use the spline parameter. Spline parameter is giving a 0 to 1 from the start to the end of a curve. Now we plug that into the fold, and I want to remap this relationship from 0 to 1 to 0, 1, 0. So that no matter how you actually increase the scale, you can see that actually the starter and the end is always staying at its position. And you can change the remap a little bit so that it might be a little bit more obvious that you can see only the top or middle part is being displaced. The rest is kept at the ground. Okay. So next thing I would like to do is to give all this kind of spline a different noise. So we take a spline info, which is essentially an index node, but they interpolate the domain at the spline domain, so that it gives you a spline index, which you can use as a seed. So now, even if at low frequency, you can see they are very different from each other because they are using a different seed of noise for every spline. So the rest is just a parameter thing that you can control this kind of scale and so on. Okay. And I want to connect all this kind of forth to the animation I've made earlier. So we take a mask node and we multiply this relationship with the forth we created earlier. So we plug this forth into this multiply. So now if we play this animation, you can see initially there is no noise. Everything is straight up to the sky. Okay. Everything is straight up to the sky, and then as you expand them, they have a kind of noise. And I want to reverse this relationship. So I just duplicate this remap 0 to 1 and reverse 0 to 1. And of course you can increase the noise. So now what it will look like is you play this animation, and when it's 0, you do not have all this kind of knitting unit, but you have this kind of straight line due to this displacement. So we have to solve this problem as well. There are many different ways to solve this problem, and there are pros and cons for every method. I think the easiest method I can tell you is to use this delete geometry, and we're going to delete spline. Now we do not have anything in the viewport because everything is being deleted. So in order to recover our spline or curve, we have to deselect that. The idea is still using this forth, and we can use another color ramp, or you can use the compare. It's the same. Sometimes it's better visual by using this color ramp because you can scroll that easily instead of using all this kind of dead number. And basically the 0 means no, 1 means yes. So we need to reverse this relationship. We have yes at the beginning, and we can switch that to constant. Basically the value between 0 and 1 is also yes, but it might be easier if we just use constant. And we plug this color ramp result into this delete geometry. We do not have any change in the viewport, but at least it's expected that we do not have anything or ugly straight line when it's for animation 0. So now if we play this animation, so we start to have all this kind of displaced knitted unit, and everything shows up. Okay. There's one problem I noticed, that the noise does not disappear. This is because how this forth is essentially constructed. You can have a preview. So you can preview this forth, which looks like this. It's not fully white because there is some gray area. This means this forth does not actually reach to 1. If it does not reach to 1, then you cannot really reach all this kind of 0 or 90 fully. To solve that, it will be easier if you just make this forth animation to 2. So you have real completion of this animation. So you start from black, becomes a little bit gray, and finally everything reaches to 1. So this is the trick of using this proximity forth. I've discussed this concept in the past. So this is the idea. Okay. So now if we delete this viewer, you can play this animation and you see how it goes. If you want to change the rate, for example, you want all this kind of disappearing of noise quickly, then you just use the color ramp and make it sharper. So we have this. And you may also want to animate the noise. If you animate this noise, you can use the same method as previously, where you use the translate position into this custom vector. We can even use the same translate position, and then we play this animation. So if I play on the timeline, you can see all this kind of noise is displacing themselves, waving. So this is the idea. Okay. Next, I want to talk about the second part of instancing. Instead of just instancing this knitted unit, there is a lines being instanced. And basically, we are using the same phase points. We're using the same phase points. And we're deleting geometry or separated geometry. In fact, the separated geometry and the delete geometry is basically the same. So here I probably use the separate instead of delete. And we're also using the same fourth. Let's plug that into the separated geometry because I only need a rim of it. Okay. And I can use a group input to control this fourth animation. So that instead of going between the node tree, I can control that in this modifier panel. I think this is easier. And I just need to construct a relationship of a black, white, black. So only a rim of it. And we're using this point to instance. So let's take a point instance. We can instance curve linear, and we are not going to center that. Take that into the z-axis. We can take this position. So now, if we join these two hair system, so we take a join geometry. So now you can actually see how this animation is going. So we have this thing going on, and we can increase the length. Okay, we can also rotate it. How to rotate it is a very interesting question. There are billions of ways of doing it. I think one kind of method is just to transform it. So we transform this grid, so elevate it on the z-axis and scale that up a little bit. Okay, and then we sample the position, sample index, and we sample the position. We transfer the position essentially, and we use this position value as a guide for align ruler to vector, and make sure that the axis is looking at that, and plug that into the rotation. So now it looks like this. So you can change these changes, make it smaller. So finally you have these patterns, and you can play these animations. Finally just showing up, and that's it. Okay. And talking about the texturing, as last time, we are going to take the UV. In 3.5, there will be a UV socket, but I'm using 3.4 now. So we store name the attribute. We can use the vector or whatever, and then we can store in the face corner. But in 3.5, there is a kind of 2D vector instead of vector, and there will be a UV socket, so that you do not need to use name the attribute. It just makes some convenience or not, but anyway. So we take this tiny UV map, put into the value and take UV. In order to give everything a material, we need to set a material. Previously, I've already made a material on a curve. So let's just name as a tutorial. So we take this tutorial. So now if I go to the shader editor, we have this image texture. If I go to the material preview mode, you can see there is nothing because the UV, actually it does show the UV, but it looks kind of very ugly because it's repeating pattern and many other issues with it. So we take a store named attribute, we take the attribute. So it's called UV. Plug that into the vector. So now it actually shows the result I'm looking forward to. So the rest is parameter things. For example, you're just increasing the subdivision, so you make that clearly. So this is it, and you can see a lot of details. You can add more details to it, but I think this tutorial is already long, so we're going to repeat the same procedure in the next tutorial, and we are going to add more details in the future. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.